All right, so in this video, we're going to start to do some more advanced problems. And if you look at this cheat sheet, I have copies of this in class if you'd like to get one to help you to start. This shows the process of performing stoichiometry problems of any type. So there's a couple of things that we need to remember about stoichiometry. First and foremost is that when we're dealing with the performing a stoichiometry problem, we must have a balanced equation so that we have the accurate recipe for the chemical reaction and the relative amounts of reactants and products. The next thing is that when we perform a stoichiometry problem, it's always between an amount of one thing and an amount of another. And it could be a reactant to reactant, reactant to product, product to reactant, product to product. That doesn't matter. But the only thing that are involved in the reaction or in our calculation is the two things that are being addressed in the problem. So far we have just been doing very simple problems where we have been going from moles of one substance to moles of another substance. And that is relative amounts of things. But we learned in Unit 5 that we can measure amounts in different ways. So we can measure the amount of a substance in grams, in representative particles, and in volumes at STP. So using this conversion factor here, we can go between moles of a substance and another amount. So remember, if we are going to go to molar or from grams to moles, we use the periodic table. Representative particles, we use Avogadro's number, and gas volumes at STP, we use 22.4 liters. So in these more advanced problems, we are going to be looking at trying to go not just moles to moles, but in any relative amount to another relative amount. So in this video, I'm specifically going to give you examples of grams to moles problems or moles to grams problems. All right. So this is the first example I'm going to do. It says that we have how many grams of barium carbonate would be produced from 6 moles of ammonium carbonate. And I have the balanced chemical equation here, so I'm ready to get started. So I always start by writing the number I have first. So the number of what I am asked, or that the number that I'm given would be here. I'm starting here. I'm told that in moles. So I don't have to worry about this very first conversion. I'm just going to start with my first step to go from moles of substance 1 to moles of what I'm asked to find. So that's the same as we started last time. So I have 6 moles of ammonium carbonate. Oops. And I want to go for moles of I want to find moles of barium carbonate first. So I'm going to use the balanced chemical equation, and I'm going to see, okay, the ratio is actually 1 to 1. So 1 mole of barium carbonate goes on top, and then the 1 mole of ammonium carbonate goes on the bottom. Okay, so that my moles of ammonium carbonate cancel. And then I need to make one last conversion. So I've gone moles to moles, but the question asked me how many grams. So I know how to convert from moles of a substance to grams of a substance. I'm going to multiply it by the molar mass. So I'm going to say times, and I'm going to put 1 mole of barium carbonate on the bottom because I want that to cancel. And then I need to put the mass in grams from the periodic table on top. So I have to look up here, and I see that barium is 137. So I get barium is 137 plus a carbon, which is 12, plus 3 oxygens, which is 48. So I get the molar mass of barium carbonate is 197 grams. So in order to do this conversion, I'm going to do 6. The 1's cancel, so I'm just going to do 6 times 197. And I get that from this reaction, I can make 1,182 grams of barium carbonate. All right, let's go ahead and do one more. So in this example, it says how many moles of ammonium nitrate will be produced from 110 grams of ammonium carbonate. So in this case, I'm going from moles of one substance to grams of, or sorry, I'm going from grams of one substance to moles of another. So let's go ahead and write down what we have. So 110 grams of ammonium carbonate. Okay. So if I look at my cheat sheets, the first substance that I'm given, the amount I'm given in grams. So my first step is going to go from grams to moles using the molar mass conversion that we learned in Unit 5. So I need 1 mole on top and the molar mass of that thing on the bottom. So 1 mole of NH4 to CO3. And then if I had to add them up, I've got 2 nitrogens, 8 hydrogens, a carbon, and 3 oxygens, and I've already done that. And if I add all of those up from the periodic table, it actually equals 96 grams of NH4 CO3, so ammonium carbonate. And then my next step, because I'm asked moles of ammonium nitrate, is going to be here. So I've gone from grams to moles of substance 1, and then I want to use the molar ratio from the balanced chemical equation to go from moles of substance 1 to moles of what I'm asked to find. So in order to do that, I need to use my balanced chemical equation. I'm trying to figure out ammonium nitrate. So I know that there are 2 moles of ammonium nitrate made for every 1 mole of ammonium carbonate that is reacted. Okay, so then I just need to punch it into my calculator. I'll take 110 divided by 96 and then multiply by 2. I always work my way left to right. If the number is on the bottom, I divide. If the number is on the top, I multiply. So 110 divided by 96 times 2, and I get 2.29. And that is moles of ammonium nitrate. All right, so these are grams to moles or moles to grams problem. In the next videos, I'll start to do some practice problems that involve other amounts.